Hello and welcome to C++ Weekly. I'm your host, Jason Turner. In this episode, I'm going to pick up where I last left off when we were discussing link time optimization and share a very similar example related to templates. Okay, so when we were talking about link time optimization, I left off with this example of this thing that can add values, and we've got a main function that's calling an add function, that's calling this value to, and all this stuff. In the previous example, I had the add function as a regular C++ function that was forward declared and in a separate compilation unit. For the sake of this episode, I have moved the add function into being a template function. Now it knows how to add values of any two types. I'm currently doing an unoptimized build to make a point. File 1 is calling the add function, and file 2 is also calling the add function. I have the output of file 1 over here on the right-hand side, and we can see that it has an implementation of the add function. And if I change to look at the output of file 2, then we can see that it also has an implementation of this add function. Now the add function is very small, so it doesn't take much effort for the compiler to compile it. But the fact remains that the compiler did have to compile this add function twice because it's a template. That's how templates work. The function is going to be automatically created dependent on the types that were provided to it, and the compiler is going to have to figure out what that means in the context of every file that you compile. So C++ 11 added this feature called extern template. And the whole goal was to make it so that you didn't have to recompile these template functions every single time you went to use them by telling the compiler, I promise that somewhere there will be a version of this template that has already been created for you. So first of all, I'm going to put this in O3 just to show you that this add function does still go away in the case of an optimized build. And that's going to be important information to keep in mind. So here, where I have declared this template function, I'm telling the compiler that somewhere there will be provided for you a version of this template. You don't have to worry about compiling it right now because a version will exist. So I have declared the extern template, but you can see I am getting this build error, undefined reference to int add int int. So this is how I declared it. I'm saying it is a version of the add template function with an int parameter that takes an int, two ints, and returns one int. So I need to now actually have the compiler provide this instantiation of this template function for me. And it is just that simple. I have in this C++ file asked the compiler explicitly to create this template function for me, and I no longer get the linker error. And I've saved the problem of each file having to create its own version of this template. But I've created a new problem because, well, is it a problem? It depends on your perspective. If this add function were very large, requiring instantiation of many other template functions, then I could have just made a considerable compile time performance improvement. And I have actually used this in real code to make a significant impact on build times. But now I don't get that optimization that I would really like to see. And if I go back here to the full optimized build and I'm looking at the test binary, I can see that I do actually have to call this add function many times. The compiler simply isn't able to do that kind of optimization that we wanted it to do. We are back in the world as if this function wasn't declared in a header file at all, as if we had the file implemented in a different C++ file, and now we're losing this optimization that we wanted. But we can solve that problem by again enabling interprocedural optimization, which is why I recorded the previous episode. So if I enable interprocedural optimization, then I get this argc plus 5, exactly what I wanted. In a way, we get to have our template cake and eat it too, would be one way to put this. So we get presumably very fast individual CPP file build times, much faster than if we had to create the template each and every time. And then we get to decide, do we want to enable interprocedural optimization to get back some of the potential performance that we lost, but then pay a higher price at link time? Or do we just say it's okay to out of line this function because it's a large, expensive function anyhow, and the probability that the compiler was going to inline it, even in the case of IPO being turned on, was low. So these give you all of the choices that you could possibly want. So there is another tool in your C++ toolbox to decide exactly where you want to spend time and whether or not this cross-compilation unit interprocedural optimization is important to you, or whether or not you would rather have faster link times. And just for the record, in some cases, IPO can actually result in faster overall build times and higher optimization, but I wouldn't count on it. These are all things that you have to test in your own code base, but be aware of extern template and provide these for your users. If you have a very common and very expensive template function that's used throughout your code base, if it's very expensive, it's not being inlined anyhow. So you may as well just go ahead and mark it as extern template. So thanks for watching this episode of C++ Weekly. I hope that this new tool that you may not have known about before is useful to you and that you can find a place to use it in your own code.